In this video, I'm going to describe how to install TensorRT and how to use TensorRT to speed up the inferencing processes. Okay, so if we don't use TensorRT and just use the PyTorch, the performance is much slower. Okay, later on this video, I'm going to describe why that is the case. So first of all, let me start with the installing the TensorRT on your Ubuntu system. In my case, it's on the WSL2. The Ubuntu version is 24.04. Okay, and on it, I have ROS2 Jazzy installed in it. Okay, to install it, first I need to install the TensorRT in a system-wide, and then I need to install the Python binding. Okay, the best way for you to install these things, use any of these AIs, either Copilot or Gemini, ChatGPT, Codex, whatever. Okay, ask the question, such as like I have Ubuntu 20 some version. Okay, and then I have installed the ROS2 some version in it, right? And you would like to install the TensorRT in it. Guide me. It'll tell you what to do. Okay, that's exactly what I'm doing here. I currently use Copilot to go through all this to generate all this instruction, following the step by step. Okay, so first, using these commands, you can install system-wide TensorRT and a few more libraries that are needed. Okay, and then once you install the system-wide TensorRT, then now you need to install the Python bindings. Okay, follow the commands that AI gives you. All right, anytime after when you install this, it generates an error. You copy the error and paste it on this AI. It'll get you the next step that you need to resolve the error. Okay, so once you install the Python bindings, then now you need to do the following. The YOLO version, I'm currently using YOLO version 11, right? And so you get the, well, first of all, you install Ultralytics library in your Python. And then in the either IPython or Python script, you write this. Okay, so it basically downloads the weight file. Okay, once it downloads the weight file, it utilizes it loads that onto a model, and then it'll export that weight file in ONNX version. Okay, this is a neutral deep learning file thing. Okay, so once you generate this ONNX file, you will see this file in the directory where you saved it, or probably same directory where this code runs. Okay, once you have that, the next step is you use system-wide TensorRT to generate the engine file. All right, once you have that, you use this command to generate the engine file. Once you have that engine file down, then the next step is actually use that engine file to do the inferencing. So now here is the example code for the Python node that will respond to the image that comes in. All right. So I mean, if you ask this, the AI generates all these sample codes for you. So all you have to do is ask AI to ask AI to generate this code for you. When you run this code, if there's an error, copy and paste that error into AI. It'll fix it for you. Okay. So that's what you need to do. I already have done this implementation in my node here. Let me see. Yeah, it's a one for PyTorch, the other one for TensorRT. Where's TensorRT? Yeah, there you go, TensorRT. Okay, so this long code has been generated. I believe I generate this using Gemini. So once you have all that, then it's time to run this and see their performance difference. Okay, so the first part of this video is explaining about the system that we have here. Inside of this Unity, I have this drone that's going to fly through this neighborhood, right, with the various altitude and directions. And I have a camera that is attached right here, right? And that is, as you can see from, display one. This is the camera here, and the view over here on the left-hand side is what that camera is looking outside. Okay, and this is the raw image that's going to be processed using YOLO. Okay, and so I actually have another camera that follows this drone just to show where the drone is. And so once I click on start, it'll fly through this neighborhood and it's going to process this image in real time. And we're going to compare between PyTorch version of YOLO11 versus the TensorRT version of YOLO11. I'm currently running the PyTorch version of YOLO11. And just to show you its performance, I'm printing out the frames per second. It's going around 30, 40, yeah, maximum 40, sometimes go down to 20 frames per second, right? Okay, so this is the performance of TensorRT version of YOLO11. As you can see, the frames per second, it goes from about 90 to 100 to all the way to 300 frames per second. So it's drastically faster. And I'm going to describe why there is so much difference. So the major difference between the PyTorch and TensorRT is that PyTorch, any code that you write in the PyTorch on the two different machines where they have different GPUs, it still runs as long as that both of them has CUDA toolkit installed in it, CUDNN libraries installed in it, all that. As long as your PyTorch code runs on both sides, it runs on both sides. Okay, so you write once, it runs on multiple different machines. That's why it's slower. On the other hand, TensorRT, when you build engine file, it needs to know exactly what kind of GPU hardware that you have on your machine. Plus, it has to know, like, exact CUDA toolkit model, CUDA toolkit version that you installed. All that stuff goes in when you build this engine. So, and it is compiled as C++. So it's very low level C++ code that runs directly on a GPU. That's why it gets so fast. All right. So this video is all about differentiating between PyTorch versus TensorRT, and I have shown you the performance difference. And one more time, I'm emphasizing, if you want to install these things on your machine and try these things out, use AI. And AI will describe you how to do it from step by step. And if there's any error during that installation or running your Python code, copy and paste the error message back to AI. It'll tell you what to do next. All right, that's it for this video.